All right, lots of interesting stuff going on. Let's do it. The daily space weather. Congratulations on realizing our channel exists. We've got coronal mass ejections, a tsunami warning, a large earthquake south of Alaska, and lots more to cover. All kinds of anomalies across the board. Here's the sun in 304 angstroms, ionized helium from the Solar Dynamics Observatory. A couple of coronal mass ejection events here. You can see one on the southeastern limb, as well as one in the north central area. And we've got some close-ups of that in composite imagery for you. First, let's take a look at Lagrangian point 5, stereo A's location for the coronal mass ejection. So late in the day yesterday, the coronal mass ejection that we forecasted did indeed occur in full glory. It is Earth-directed, and we can expect some geomagnetic effects from that in a couple of days. And our main focus is forecasting coronal mass ejections in this region. So just this area. We don't do far side coronal mass ejection forecasts, only on the sort of the Earth side of the sun here and up to the poles. We don't do it over here. We only do it over here. And our accuracy is still at 100%. So let's take a look at the viewpoint from L1 at the LASCO C3. And you can see ejecta here on all sides of the coronagraph. So it's not a particularly dense halo or anything like that, but there is certainly some ejecta headed Earth's direction. Hopefully there's enough contrast for you to be able to see that. Again, that's Lagrangian point 1. And let's go back to stereo A real quick. So there's the coronal mass ejection. It's quite significant. A little bit of missing data there, about 4 hours worth. But most of the coronal mass ejection showing up there on the stereo A located at Lagrangian point 5 space weather beacon coronagraph. And we've got some composite imagery for you. This is 171 angstroms and 304 angstroms. Here's some more, a close-up of this active region here. This is really one of two coronal mass ejections. They were sort of two separate events here. So here's a close-up of this one in a similar composite. 304 and 171 angstroms. And here's the southeast limb. You can see this filament ejecting out here, starting out as a prominence, and then making its way in our direction. Some solar protons headed Earth's way. Here's a quick diagram of the solar system. Here's where stuff is now. We'll advance this 1 week. There's where things will be in a week, approaching another new moon. Here's a star chart. If you're up before dawn, you may see Jupiter and Saturn and the moon up near the ecliptic. The radio flux has dropped down to 79. The upper chromosphere and lower corona do emit radio frequency. And it's a great proxy for sunspot number, as you can see here. The black line is the radio flux, 10.7 centimeter radio flux, that is. And the red line is the sunspot number. No geomagnetic storms or geomagnetic unrest currently forecasted by NOAA, although we can expect that to change coming on probably on the 31st. We'll be keeping you apprised of that. So seismicity now at very high levels as the 7 magnitude earthquake drought has ended. We now indeed have seen an 8.1 magnitude quake there south of the Alaskan Peninsula. And any viewers who felt that one, let us know. There is a tsunami warning associated with it. So beware if you're around the Pacific Rim. Tell your friends and foes. We actually made a video about this and put it out promptly. We put it out promptly. Tsunami warning as a result of that 8.1 magnitude earthquake. So we're just going to scroll up the list here. We're not going to talk too much about very much of anything. Seismicity has upticked big time, and we're going to see repeated aftershocks in that area. And when we see tsunami warnings, that's an indication that tsunami buoys have been triggered. So there was also a 5.8 at Peru. And when we get up to the list here, we'll tell you the time of that. That 8.2 originally reported 8.2 magnitude quake here occurred at 6:15 Universal Time. So just a couple hours before we made the video, and of course you're going to see aftershocks there all day long, making for a very lengthy list on the USGS page. Regarding volcanism, Mount Abico's erupting. And now a new one on the list here, Ulawun, on the Isle of New Britain, part of Papua New Guinea. Unknown volcanic ash cloud there. Don't hang glide over the caldera. Nevado del Ruiz exploding. 20,000-foot ash plume over Colombia. Revenador in Ecuador producing a 16,000-foot ash plume as it explodes, and Sabancaya similarly exploding, producing a larger ash plume about 8,000 feet higher at 24,000 feet over Peru. Please do not pole vault the caldera. It could be unhealthful, like tsunamis. And please support the channel via links at smashomash.com, the merch, the Patreon, etc. Patreon.com/smashomash. Once again, another fine example of how we don't need to see any solar flaring or even sunspots to see major coronal mass ejections headed Earth's direction. There's the X-ray flux over the past 3 days. No significant solar flares whatsoever. And if you're wondering, we consider a C-class flare significant. No spikes in the proton flux. Once again, another prime example of how no flares have occurred, and yet there's a coronal mass ejection headed Earth's way. It's part of the reason why we forecast it. And our forecasting for coronal mass ejections, if you're wondering, is at 100% for several months. We haven't missed a single one on the Earth side of the sun, and we haven't misreported one single coronal mass ejection either. Here's the GOES magnetometer over the past 3 days, and we're seeing some quite sawtooth patterns here, and it's because of some indecision in the heliospheric current sheet polarity. Let's take a look at that. Here's the top view ecliptic plane field plot, and Earth is snapping into a North Pole-oriented current sheet as we speak. If not already in one, this data is 1 hour and 42 minutes old. Here's a line-of-sight view of the same data, showing you sort of the tug-of-war going on here between the North and South Pole current sheet for the polarity of the earthly portion of the heliospheric current sheet. Here's a line-of-sight coronal hole plot, and we've got some coronal holes kicking up here. There's a trans-equatorial one over here in the east, which can't decide what polarity it is, as we see a terminator event being initiated here. Coronal holes arguing over their polarity, and a slow progression of solar cycle 25 is going to suddenly speed up. Mark my words. And the probability of major solar flares is way down. No sunspots even on the solar disk. We're at 0 sunspots. We could still see some flaring as there are some active regions. So the KP index currently at 3. It's mainly a result of magnetism and lack thereof snapping back and forth, probably repeatedly, in between the North and South Pole-oriented heliospheric current sheets. KP currently at 3. It's a measurement of global geomagnetism for you new viewers. And let's take a look at the real-time solar wind. And in the real-time solar wind, we see a signal here indicating a high-speed coronal hole wind stream. So this has been going on quite steadily here. Current solar wind remains elevated. So that's the main source of the high KP index, folks. 525 kilometer per second solar wind at a density of 6.17. It's quite a strong coronal hole wind stream there. The rest of the panes here for the real-time solar wind, fairly uneventful. But the main news is 529 kilometers a second for the solar wind speed. So that's kicking up some pressure in the geospace. Here's 4 hours of data courtesy University of Michigan. Our Geospace Magnetosphere movie will be checking auroras 2 frames from now. And we let this play through daily as the data is not archivally viewable. So there's that steady high-speed wind creating some high pressure. And the scale you're looking at here is nanopascals. This scale is in nanotesla. So we're seeing some significant ground magnetic perturbations during this geomagnetic excursion, which isn't frightening me at all, by the way. We do see significant perturbations here south of Africa, south of the Indian Ocean, south of South America, as well as major perturbations here over the Siberian North Pole, less so over the Canadian North Pole. And we actually brought up the polar view also. We're going to show you the polar view as well here. Some pulses coming out of the Pacific Ocean as well. Here is the polar view. And this high-speed wind could have kicked up some auroras. We'll show you that next. and looking at changes to Earth's B field, otherwise known as geospace delta B, gives us insights into what is going on with the polar excursion. All this data is derived from the Space Weather Modeling Framework. If you want to read about it, just click on details on these pages. You can click on the Space Weather Modeling Framework. It'll tell you where the data is derived, where the model is derived, I should say. The model is derived from a lot of data. I'll just say that. So here's the auroral forecast. A little bit of an enhancement of the aurora australis, especially as a result of that high-speed solar wind from the coronal hole. As solar protons streak across the solar system, some from a coronal wind and some from a coronal mass ejection. Let's advance that so that they're synced. Let's sync them. There we go. So not really that significant of a boost in the aurorae here. And those southern hemisphere aurorae are largely going to be visible from uninhabited locations. It is Antarctica, and it's winter down there. There are very few humans on the continent overwintering. You got to have a good back and be able to snow shovel for real. Anyway, thanks again for tuning into the video. Congratulations on realizing our channel exists. Don't forget to press like and subscribe if you enjoy the content. Tell your friends and foes about us. The algorithms dislike us. We're also on Twitter. And of course, we put up the video about the tsunami warning. Don't forget to check out our merch as well from smAsho.com. You can find a link to the smAsho merch page. Use the promo code GETDRESSED to save 25% on all clothing. And if you're viewing the videos any place besides on YouTube, make sure you go subscribe on YouTube as well, because you're missing like 80% of the content. Today's cosmology segment is going to be very short, as there's too much stuff to cover here to really talk about cosmology too much. However, here's the nebula containing Cygnus X1, believed to be a, quote, microquasar, end quote. We'll just say it's a massive radio source, one of the most powerful X-ray sources in the entire sky. Not quite as strong as the Crab pulsar, I don't think, but in any case, there's the caption. If you want to read that, feel free to pause the video. We've got to keep moving on here. Today's cosmology segment was very short. We've got some major anomalies going on with the electron flux as well, creating some charging hazards despite overall low levels of electron flux. So here we see some charging hazards over the Central Atlantic, the Caribbean, northern South America, as well as Mexico, about to move into the Central Pacific, all north of the equator there. Some surface charging hazards caused by the electrons surrounding planet Earth. Here's a one-year chart of the relativistic electron flux. That's from Solon.info if you want to look that up yourself. Solon.info/solar has all of that. Here's the 3-day chart, and we're seeing depleted levels of electron flux as a result of the incoming coronal hole wind stream. It's like a proton light event. And here's the forecast model, and you can see that dip that's caused by the coronal hole wind stream. We can expect this to remain at lower levels here until the coronal hole wind stream subsides. And check out the chaos going on in the total electron content. We've got major anomalies here once again near the Antarctican continent. So we've seen this several times. This is actually one of the more major ones. We've documented this several times on the channel here. South of Africa, south of the Atlantic Ocean, and south of South America. Major electron flux anomalies. It's almost like an additional Van Allen belt forming down there. And we typically see the most chaos in the electron flux when we see low levels of electron flux overall. The low electron flux seems to be associated with changes to Earth's magnetic field. Electrons respond more quickly to the magnetic fields than anything else, as electrons only weigh about 1/1800th of what a proton weighs. We'll let this play through a second time to show you those anomalies. Once again, this shows you the total electron content for the entire air column, showing you electron density from about the level of a GPS satellite down to your handset, potentially. Here's a diagram of the atmosphere. Feel free to pause it on this frame if you like. Next is the F ionosphere layer, one slice of the atmosphere and vibrational frequency. It's the bridge between space and Earth. And we're seeing some anomalies here as well. And those are in the form of some sudden charge ups here over places like Africa, and then some sudden charge downs in the northern hemisphere. Surprisingly high vibrational regions in the Central Pacific Ocean. And if you don't look at this every day, you may not understand what an anomaly looks like. We just show the data every day, 1 day's worth, and then we bring up the latest frame like this. That's the latest frame there from 7:30 Universal Time. Things looking highly low vibration at that moment there, only making it up to 8 megahertz. It looks like what we saw for extended periods during the most recent solar minimum around late summer, early fall, late summer through the fall of 2019. So we're going to do a meteorology segment as well, folks. Make sure you check that out if you haven't. And we've got another meteorology segment in the books. Make sure you check that out. There's a playlist for it, youtube.com/smashamash/playlists. Here come bonus features, the Lermonth ground-based observatory first. So there's the ground-based observatory data from Lermonth, Australia. And the possibility for additional coronal mass ejections remains, folks. We see lots of filaments here on the Earth-facing portion of the disk, all these dark regions. They could eject with basically no warning. So stay vigilant. We'll let you know if there's additional watches. But we're not issuing one at the moment because there's simply too much stuff going on. So here's the GOES 16 SUVI map, and you can see a little bit less filaments on the sun than we saw yesterday, as some of those have ejected and they're headed right to your doorstep, essentially. Here's the latest intensity gram. We're going to press refresh to show you 0 sunspots. Again, we don't need solar flares or sunspots to see coronal mass ejections. There's the colorized magnetogram in high res. And we'll close out today's daily space weather video in 171 angstroms and colorized magnetogram from the SDO Browse data site. Thanks for tuning in. Congratulations on realizing our channel exists. And may that solar wind be at your back.